Hello, today we are going to be writing a two-column proof. So by the end of the day, you will be able to say I can write a two-column proof. And they look something like this, and by the end of the day, you'll feel more comfortable with them, hopefully. Now, we're going to find out, yeah, we need to know that there's a difference between congruent things and things that are equal. Now, if they're congruent, that means that two objects are the same size. Say this angle and this angle. Now, adding them doesn't make any sense. So if we want to add, we need to convert this to talking about the measures of the angles, because we can set, so the angles being equal, we can do things, because this represents a number. And numbers we can add, subtract, multiply, divide, so on. And the reason we can go back and forth between these two things is that's the definition of congruence. We're going to use this a lot in the proofs that we do, so we need to know what that is. Similarly, between segments, we can't add a segment to another segment, but we can add the numbers of the segments. So this just represents the distance from A to B and the distance from C to D, and so we can do things with that. Just remember, you cannot do math and calculations with an object. You can only do calculations with numbers. All right, so here's the real deal. We're trying to do this proof. It says we know angle 1 is equal to angle 3, and we want to prove ABD is congruent to CBE. Well, we can start this proof by writing the given information. And over here, we always write given for blank number 1. Now, since we know that the angles are congruent, we know that the measures could be equal. And this is what I was talking about on the preceding page. And that's because the definition of congruence. Now, once we have those, now we want to say measure of angle 1 plus measure of angle 2 is equal to 2 plus 3. And the reason why we can say that is really what we did to both sides of this equation is add the measure of angle 2. So this would just be the addition property. Now, measure of angle 1 and angle 2, why do these two angles add up to this big angle? And we learned yesterday there was a postulate for adding angles, and it's called the angle addition postulate. And that just says that two smaller angles will equal the bigger angle if they're sharing a side. And now if we have those two angles adding up to being the bigger one, also angle 2 and angle 3 will be CBE by the angle addition postulate. Now let's take a look for a second. I think this got a little bit off. Let's get rid of this. Let's just slide this down just a little bit. Instead of writing that one again, I'm just going to slide these down just a tiny bit. And both of those are angle addition postulate. So now if we have this situation, we know this is equal to this, but I can substitute ABD in for these values and CBE in for those values. So we can set these equal to each other by saying substitution. And if we have them equal to each other, we can change them into being congruent because that's the definition of congruence. Now we have just finished the proof, and we went from the beginning to the end, and we went through this logically to get to the answer. All right, let's try another one. This is a segment one. We're given that AC equals AB plus AB, and we want to get to AB is congruent to BC, basically saying that that's a midpoint. So we're given this first piece of information, so we just write given. Now AC is AB plus BC, So why is this big one equal to the small one plus the other one? That's the segment addition postulate. There was the bell. So now if this is true, AC is equal to both of these things, we can set these equal to each other by using substitution. Or it's kind of like the transitive property as well. Now once we did that, if I just subtracted AB from both sides, we can get this next row. So that would be the subtraction property. And now if we know these two distances are equal, the two segments are going to be equal because that's the definition of congruence. Hopefully you're getting the hang of this a little bit. They're a little confusing at first. The more you're exposed to it and we'll look at these, the easier and easier they become. All right, now we're not just filling in answers, we're also filling in the left side too. So we're going to start with 1 and 2 form a linear pair, and measures of angle 1 and 3 add up to 180. Prove that 2 is equal to 3. Well, the first one, both the first two are true because those are given. And now the second one says linear pair of angles are supplementary. So if that's supplementary, we would say angle 1 and angle, or we could say just like the next row, angle 1 is supplementary to angle 3, or angle 1 is supplementary to angle 2. And that's linear pair. And why are they supplementary? That is the definition of supplementary, that they add up to 180. Now, the last statement of proof is always going to be what we're trying to prove. Angle 2 is congruent to angle 3. And that's the congruent supplements theorem. This is a little bit more complicated theorem. It's kind of like a transitive property with supplementary angles. It's saying if 1 and 2 add up to 180 and 1 and 3 add up to 180, then these two have to be the same. All right, hopefully that makes sense. We'll do one more and call it a day. Now we have these. We know AB is congruent to DE and BC is congruent to EF. We want to prove that AC is congruent to DF. Well, we have that first statement. That's given. Now, if we know those are equal, the definition of congruence of segments tells us that AB is equal to DE. Now it's looking for the other piece of given information. BC is congruent to EF. So then why is BC equal to EF? That's the definition of congruence as well. Now, why is AB plus BC equal to DE plus EF? Well, we're just adding these two and those two, and since they're equal, that'll be the same. So that's the addition property. And now AB plus BC equals AC, and DE plus EF equals DF. Now if we look up back up here, AB plus BC, why is that equal to the big thing? And same thing here, DE, EF. That's called segment addition postulate. So now once we have that, we can know AC is going to be equal to DF by substitution, because we know that these two are equal, and we're just substituting that in there, that in there. So then we can say AC is congruent to DF, and that's the definition of congruence. Hopefully these are starting to make more sense. The more we do them, the more you will feel comfortable. Now rate yourself on your understanding, and hopefully try to increase that. Thanks.